Hello, this is Mr. Fontenot. Welcome to my YouTube page, Mr. Fontenot 1111. In this video, I will be going over the directions for Workbook Activity 8-1 found in the Chapter 8 module, Workbook Activity 8-1 Assignment. So I'm starting here on my on the Canvas page for Temperature and Analytical, INST 2732. I'm going to scroll down to the Chapter 8 module. I have a scan of the workbook page here, just to show you what the page is that we're working with. I know that all of you have the workbook. The next thing is the assignment itself. I'm going to go ahead and open the assignment, and really what you can do is go ahead and open Canvas a second time, and the easiest way to get to Canvas is through Suella's homepage. Just go to Suella's homepage, click on Canvas, log in, go back to the class, and I'm going to scroll down here because I'm going to need this Type J reference chart open. So I click on that, and you can see it opens it in another tab. Click on the tab with your Canvas page. Go back to the Canvas page, go back to the module, and go ahead and open your Type K as well. So you've got your Type J open, you've got your Type K open, and we've got the assignment open here. Now, Canvas calls anything that you do electronically on their platform a quiz, but this is not really a quiz, it's homework. So we look at number 1 here. This is where we're going to just type our answer, and this is a numerical answer only. And if we look at the assignment, it says Activity 8-1 Thermocouple Calibration, a millivolt generation instrument without ice point compensation can be used to provide thermocouple input signals for calibration of temperature transmitters. The ambient transmitters are provided. Determine the millivolt output to obtain the stated calibration point temperature. Use the thermocouple voltage table in the appendix. So if you don't want to open up the Type J and the Type K, make sure you use the Celsius chart. If you don't want to open up on your computer, they're also in the appendix of your workbook. And so you're going to have the Type J and Type K handy, as I said, either in your workbook or on the screen. Alright, so the first thing it says, given a Type J thermocouple with an ambient temperature of 20 degrees, answer the following question. The calibration voltage input signal at 0 degrees Celsius. So I made a little spreadsheet here to make this easier to understand. Alright, so looking at number 1 here, the first thing you're going to do, they give you 0 volts here in the sentence. This is your current temperature is 0 degrees Celsius. I'm sorry, I said 0 volts. I meant to say 0 degrees. So your current temperature is 0 degrees Celsius. You're going to look that up on the chart. So I go to my Type K because I'm dealing with Type Ks right now. I go to my Type K, I look up 0 degrees Celsius. It's right here. So 0 degrees Celsius is 0 millivolts. That's my first number, 0 millivolts. Then I look on the exercise and I see that I have an ambient temperature of 20 degrees Celsius. So I go to my Type J reference chart and I look up my 20 degrees Celsius and I see that that's 1.019 millivolts. So that's going to be the second number that I need, 1.019 millivolts. Alright, so I have here a column for current temp and a column for ambient temp. So the ambient temp for every problem 1 through 5 is 20 degrees Celsius. For 6 through 10, it's 26 degrees Celsius. For 11 through 15, it's 35 degrees Celsius. You can see that here. Type J, they give you 20 degrees Celsius. Then for the next 6 through 10, they give you 26 degrees. And then for 11 through 15, they give you 35 degrees. So for your ambient temperature, that number is going to stay the same each time. So for example, for 1 through 5, your ambient temperature every time is 20, so your millivolts is going to be 1.019. 1.019, all the way down here. But my first sentence told me 0 degrees Celsius, which is 0 millivolts. So on my calculator, I'm going to take 0 minus 1.019. So 0 minus 1.019 gives me negative 1.019. Now we're going to do rounding. Second number after the decimal place is what we're rounding. So I got a 9 here, so that tells me that my answer would be negative 1.02 millivolts. Alright, for the next one here, I see that my temperature is 100 degrees Celsius. So I'm going to go on the type J reference chart, and I'm going to look up 100 degrees Celsius. So the way that this chart works, this is 100, this is 101, 102, 103, 104, 105, 106, 107, 108, 109, 110. Then you start here again at 110, and you see these two numbers are the same, 5.814, 5.814. So this is 110. Then you come back here, this is 110, 111, 112, 113, 14, all the way up to 120, 120, 121, 122, like that. So I look up my 100 degrees, and I see that my 100 degrees is 5.269, and I recommend that you make use some kind of spreadsheet like this here, because it's just so much easier to keep all your information laid out nice and neat and understandable. So I look up my 100 degrees Celsius, and that tells me that 100 degrees Celsius for a type J thermocouple, I'm going to produce 5.269 millivolts. I can double check that right here. 5.269 at 100 degrees. These are my temperatures. So at 100 degrees, I get 5.269 millivolts. And my ambient temperature, as I said, stays the same for 1 through 5. It's still 20 degrees. So on this one, I'm going to take the millivoltage that I get at 100 degrees Celsius, which is 5.269. That's my current temp minus my ambient temp millivoltage, which is 1.019. And so I get 4.277. We're going to round, and it's going to be 4.28. Sorry, must have typed that one wrong. 4.28 millivolts. All right, let's do one more, and then we'll type some numbers into our assignment. Okay, for the next one, if you look on your workbook, it says the calibration voltage input signal at 200 degrees Celsius. So it's not saying the voltage, it's saying the calibration voltage. So I look up my voltage for 200 degrees Celsius on my type J chart, and I see here that it's 10.779. So my first number here is going to be 10.779. My second number, which stays the same, is 1.019, so I'm going to go 10.779. minus 1.019 equals, and it's 9.76 millivolts. All right, when you get down to number 6, your first one again is 0, but you got a different ambient temperature, and now you're using type K instead of type J. So you got to change charts and use a different chart here. Your type K chart. Same process and procedure though. So for instance, the first number they gave me, the first temperature they gave me right here was 0 degrees Celsius. So that 0 degrees Celsius, I look it up and I got 0 millivolts. Then my ambient temperature for each one of 6 through 10, number 6 through 10, is all 26 degrees Celsius. So for 6 through 10, once I look up my ambient temperature millivoltage amount, if you go look up 26, so 20, 21, 22, 23, 24, 25, 26, it's 1.041. Once I get that number, 1.041, it would be the same for 6 through 10. I just didn't type it in every time. So I'm going to take my current temperature and I'm going to subtract my ambient temperature millivoltage from my current temperature millivoltage, and that's going to give me my answer. So let's look at this one. 4.096 minus 1.041. So it'd be 3.06. Now I am not putting in 4.096 times 10 to the negative third minus 1.041 times 10 to the negative third. I'm not putting my engineering in here into my calculator, even though, yeah, it is a millivolt. But as long as they're all in the same units, you don't have to do that as long as you understand what unit you're working in. So I understand that this is a millivolt answer right here, even though it doesn't have the engineering notation displayed on the calculator. As long as everything's in milli, or everything's in micro, everything's in kilo, if everything's in the same metric prefix, you don't have to type in the engineering as long as you know what you're working with. Alright, so my first one is negative 1.02 millivolts. So we go to our assignment here. It's real simple. Hit negative 1.02. Don't worry about the millivolts part. It's a numerical answer only. Alright, the next one is 4.28. Okay, so you're just going to type your numbers in, and that's how you do this one. Hope you enjoyed this video. Hope it helps you out.